first stage. The first one. This is your chance to ask questions before your tests. If you don't remember how to do something, today is your chance to ask. So let's start with those with the horrible attitude. Right. For number 1, your factoring objective is just, do you know which method to use and how to factor it? So for number 1, we have 2 terms that can either be difference of squares or GCF. Which one can we use here? The perfect squares. Are these perfect squares? No. So GCF, and then find what they have in common. If you wanted to do that in your calculator, go into math, over to number, and then down to GCD, number 9. And you could put in both of those numbers. It doesn't matter if it's positive or negative, it's going to take it either way. And then put that in with a comma in between. I did this last class, so you see what the GCF is. What else do these 2 have in common? B. So if I were to divide out 7b from both of these, what's left? 4a squared minus 9. And then you have to look and see, do you need to do anything else? Is this done? Or can you keep going? Difference of squares. Yes, you can keep going using difference of squares. These are both perfect squares. So you're going to break that down into what times what would give you 4a squared, what times what will give you 9. 2a and 3. And you would put the 2a first, the 3 last, put a plus, put a minus in between one, and then the other. And then once you see that there's nothing else that can be done, that would be your final answer. Questions? So you want to factor this as much as possible. Number 3. This one has 4 terms, so we can factor this by grouping. If it has a GCF for all of them, do that. Otherwise, you can do that later. Split that down the middle. What do those first 2 have in common? X squared. If I divided that out, what's left? X plus 2y. There we go. Word is not like me today. Right. What about the last 2?
Negative 4 factored out with x plus 2y.
Negative 4 and then x plus 2y. When you factor by grouping, you want your insides to be the same. So if I rewrite this, we have x squared minus 4. And x plus 2y. Can we factor either of these again? Yes. Which one?
The first grouping will be different squares.
Correct. You would just bring down that last one. So if we split that, what times what will give us x squared? What times what will give us 4?
X minus
X minus 2, x plus 2. Those would be, all of that would be your final answer. Now, if you wanted to check this in your calculator, not Desmos, this one wouldn't be one you could check because of the 2 different variables. The last one, same thing because of the 2 different variables. But one like 4 or 2 or 5, because it only has one variable, you could check that in your calculator. by putting in the original and putting in your final answers to see where they cross. Questions on this so far? Six, we do have a trinomial, but look and see, does it have a GCF? Yes. What is that GCF? 3, is that the only thing? 3, x and y. And then if we divided that out of each term, what's left? X, y, minus 2y plus 1. Now, what's left is still a trinomial, but the first term is not squared, so I cannot do anything with this. It's not one of our trinomials we can factor. That is it. Other factoring questions? 10, sure. 10 is one of our trinomials where we're looking for what two numbers multiply to be the last term, but add to be the middle term. Add or subtract to be the middle term. So you can, yes. So you can either think of all the factors, list them all out, or just find the two that work. -8 and 2 work. And because this is a trinomial where a equals 1, you go straight into those factors. Whatever the variable is, put that first. And then the two numbers, you just fill those in. K minus 8, k plus 2. This one you could check in the calculator, put the original into y equals, but change the variables to x. Put in your two factors and see do they cross your quadratic at the x-axis. Other questions? Or questions on the back? So starting with 13, we have two terms. How could we start to factor that? Thank you. GCF. What would the GCF be? 6. 6 would be the highest. 6a. And what would be left? 4b plus 5c. Can I do anything else with that? No, that is it. is 4 terms. So factor that by grouping. It doesn't have a GCF for everything, so we don't have to worry about that. What would the GCF for the first two be? 3. Something higher. 9x squared. Leaving x plus y. What could we factor out of the last two? -1. Leaving x plus y. Whoa. And then we have 9x squared minus 1 and x plus y. Could we factor either of these again? Yes, the first one by difference of squares. I'm going to write that here. What would those two factors be? 3x minus 1, 3x plus 1. Or vice versa. then the last one. Does that one have a GCF? 18, sorry. 2, yes. I just realized I didn't do something. So if I divide them each by 2, what's left? W squared plus 19W plus. So then we're looking for, we have a trinomial as a equals 1, two numbers that multiply to be 70, but add to be 19. What are factors of 70? What did you say? 35 and 2. That would not add to 19. 14 and 5. Would that add to be 19? Yes. So those would be our two factors. W plus 14 and W plus 5. So again, if you wanted to check that in the calculator, type in the original, type in the two factors, not the 2, and they should cross at the x-axis. Other factoring questions before we move on to dividing polynomials by binomials, by monomials? Yes. 20 and 24. So 20, how could we start to factor that? Difference of squares. It doesn't have a GCF. What would those two factors be? 10 minus 3y, 10 plus 3y. 24. Does that have a GCF? Or what else? X, Y. So does everything have an X? Just Y. What would be left? Minus 6x plus 9. So then it'll be very similar. We're looking for two numbers that multiply to be 9 but add to be negative 6. Yes, they would both have to be negative. Your two factors, x minus 3 and x minus 3, or you could put x minus 3 squared. Either or. Other questions? Look at the dividing polynomials by a monomial. And find any of those we want to see you go over, have questions about. 15. There are two different ways to do this, either by separating or by factoring out the GCF. You can choose which one, but we'll do one of each and then we'll choose the last one. So for the first one, let's separate each term over the denominator. And then we're going to divide each piece using our exponent rules. Actually divide the numbers, subtract the exponents. We have 4a to the 6, b squared, c minus 1. And that would be your final answer. Questions on that one before we do 20? Yes. Sure. So 18, we're going to use the second method, factor out the GCF. Of the numerator, what would the GCF be? -3. And is that it? Nice. Divide that out of each one, what's left?
-8x.
That would be a positive 8x to the 6, yes, minus -3x squared plus 5. Normally, yes. If your GCF and your denominator are the same, those would just cancel and whatever's left would be your final answer. But because that's not the case here, we have to simplify it and then factor that back in. Sorry. So we could divide just that part, -3x over 3x to the 5th. I'm going to leave this like this for now, and then we'll switch it. And then leave everything else in parentheses. And then because I have something left outside, I have to, 1, change this to a fraction, and 2, distribute that back out. So change it to a fraction first, distribute it to each term. I'm just going to rewrite it first, and then we can simplify. You could have simplified instead of doing this and the next step. I'm just showing each step. And then divide each one separately. -8x squared plus 3. This will be x to the -2 or just over x squared. And this would stay the same. So if we had separated instead of factoring out the GCF, we would have got that a lot faster. Questions on that? That was 18. So 20. Do we want to separate or GCF? If I separate these, rewrite each piece, each term over the denominator. And then divide both terms. x cubed y squared z plus 2x squared y should be the final answer. And then we'll really quickly do the last one, separating or GCF. If I heard separate first, but if you want to do the GCF, go for that. I don't have space here, so I'm going to do this here. Separate each term, put it over your denominator, and then divide. Oh, that's it.
So why don't you GCF when you're separating? It's so much easier.
Preference. When we get back, we're going to start the binomial.
-8 and -1 don't cancel out.
No. So you have to factor your numerator and then factor, or sorry, cancel the like factors.
6 and 2.
6 and 2. Unless you're finished with yours.
One more.
Alright, so in number 2, we're going to factor the numerator. That is one of your trinomials where a equals 1. So we're looking for two numbers that multiply to be -45, but add to be -4. What numbers will work for? So because this is at a equals 1, go straight into your factors. M minus 9, m plus 5 over your denominator. Cancel any like factors you have to see what's left. So these you could check in your calculator by putting in this original into y equals, changing your variables to x, and then seeing the line that pops up. You could count your slope and count your y-intercept, or look at your y-intercept. You should see it at 5 with a slope of 1. Or you could look at your table to count the slope. Yes.
Does the a equals 1 hold only apply when dividing binomials?
It's for trinomials where the coefficient in front of the squared term is 1.
I'm looking back at 10 on the page 1, and in that one we didn't do that.
Correct. We just factored. We didn't divide.
When
because
is
this
the-
one is divided.
I'm just confused when it applies.
When it says factor, just factor. When dividing, factor, but then divide. Other questions on 2 before we do 6? How could we factor the numerator for number 6?
Yeah, we just like 5 to 10 to
5.
15 3. Like 5.
So we couldn't do that. unless we separated it, which would be more than what we want, but we could factor it by doing 1. Just so you understand what I just said. When we were separating the polynomials by monomials, there was 1 term over here. If we wanted to divide this, don't write this, it would be this over 2x minus 3 and negative 15 right here, over 2x minus 3. It's not the same thing, which is why we can't do it that way. GCF for difference of squares. What is the GCF? Wait, of what? Of the first 5, which will leave us with 2x minus 3. And those are our like factors, so our final answer is 5. Other questions on this page or the back? Mine on the back. Okay. These ones are in a different format, but you're doing the same thing. You're still dividing, factoring, and dividing. So if you want to rewrite it first, you can do that. If you want to rewrite it after you have your factors, you could also do that. So this is at a equals 1 trinomial. So we're looking for 2 numbers that multiply to be negative 33. That would add or subtract to be 11 and negative 3. So our 2 factors would be c plus 11 and c minus 3 all over c minus 3. What's your final answer? As a general hint rule, while you're factoring these, if one of your factors is not the denominator, something's off. Other questions on this back page? They'll be similar. There'll be a mix of these and the dividing polynomials by monomials. Yes.
16 and 15.
15 and 16.
Or not 15, 15 and 16.
15. Okay. These are both the same type. Jackson, pick one.
I'll just do 15.
So these are both grouping. I'm going to split that down the middle. What could I, what's the GCF of the first 2? X squared. What would be left? X minus y. What could I divide out of the last 2? Negative 6. Leaving x minus y. Put all of that over your denominator. Then rewrite your factors. So our final answer is x squared minus 6. If this was x squared minus 4 or 9 or 16, some perfect square, we would have to factor that again. But this one is not the case. Other questions on this? I'm going to give you a couple minute break before we jump into Unit 10. Go to the bathroom, go get water, walk around the room, stretch for a couple minutes. before we do Unit 10.